Hello and hi everyone. So today we are going to look into topic 4, functions. There are 4 subtopics in this topic, which are relations and functions, type of functions, composite functions, and also inverse function. So for the purpose of this video, we are going to look into the first part of this topic, which is relations and functions. So the learning outcome for this subtopic is to discuss concepts of relations and represent relations as mapping, ordered pairs, and also graph, to introduce functions as a special type of relation, to represent functions as mapping, ordered pairs, graph, and the last one is to define the domain and range of a function. So now we are going to look into the definition of relation. The relation between sets x and y is correspondence between elements of the set x and elements of set y. So the elements of the first set, set x, is called domain, and the elements of the other set, set y, is called range. The relation can be represented by three forms, which are arrow diagram, mapping, ordered pairs, and also graph. So let's look at the first example here. So when we have set x and the elements are 2, 3, 5, and set y, the elements are 7, 8, and 9. So to make a arrow diagram or a mapping diagram, we should know which one is which. So when set x, we group it together, the elements 2, 3, and 5, and set y, we group it together as well, 7, 8, and 9. So we know that the above diagram shows that the relation is a factor of between set x and set y. That means the elements of set x are the factors of elements of set y. Alright, so for example, maybe 2 is the factor of 9, so we map 2 to 9. Alright, and for ordered pairs, the same goes as well. We know that the first set is domain and the second set is range. So for ordered pairs, the pair should be domain and range, then domain and range, then domain and range again, until you are run out of elements. Okay, so this goes like when 2 is mapped to 9, so the ordered pairs is 2 and 9. Alright, for graph, so we use the same sets and same elements. So for x-axis is the domain set and the y-axis is the range set. So we just map together. So 2 is mapped to 9, so look at the so we just match it 2 to 9, so it's here, 3 to 7 is here, 5 to 8 is here. Okay, so now let's look at the first example. So the first example is to list the ordered pairs shown in the mapping diagram. So that means we have to transfer these informations into ordered pairs. So we look at here, set A, it has the element of 1, 2, 3, 4. Set B has the element of 3, 6, 9, 12. So we know that the first set is called domain and the second set is called range. So to transfer it to ordered pairs, we should know that ordered pairs is a pair of domain and range. So we look at the first element in set A here. This is the domain, it's 1, and the range is 3. So the ordered pairs is 1, 3. The same goes to 2, which is mapped to 6. So the ordered pairs is 2 and 6. For 3 as well, 3 and 9. So the pair is 3, 9, and 4 and 12. And the same goes to the second one, set x, which has 0, 1, 2, 4 as the elements. Set y has 0 to 3 as the elements. So the ordered pairs, we look at the first set, the domain, and the range, and then we pair it together. Alright, the next example is to draw a mapping diagram of 0, 4, 2, 6, 3, 5, and 5, 9. Then we need to represent it on a graph. Alright, so here is ordered pairs. So we need to transfer ordered pairs into mapping diagram or arrow diagram and also into graph. So here is the mapping diagram. So set A and set B, whichever sets, because it doesn't mention here, set A, set B. So we know that the first pair of each pair in the ordered pairs is the domain. So we put it in set A, which is 0, 2, 3, and 5. 0, 2, 3, and 5. And then the set B is the range, which is the back end of the pair, 4, 6, 5, and 9. And then we map it lah. And then we map it because 0 is mapped to 4, so 0 is mapped to 4, 2 is mapped to 6, 3 is mapped to 4, 5 is mapped to 9. And for graph, alright, so the x-axis here is the domain axis, and this here is the range axis, remember. So, and then the elements of the sets, respective sets are here, and then we just map it. Like 0 is mapped to 4, 2 is mapped to 6, 3 is mapped to 5, and 5 is mapped to 9.